today we have Grace who's here to talk to us about building modern apps, which just sounds really fantastic and interesting. I will let you do your own introduction, Grace, so that I don't get it wrong and I'm not too flippant about it. If anybody has questions as we're going along, the plan is put them in the chat and I'll capture them. And then I think what we'll try and do, Grace, is at some point when you're ready, we'll stop and go through in the Q&A.
Yep. And
deal with those things. Okay. So without any further ado, if you're ready, I'll hand over to you.
Yeah, thanks very much, Steve. So hi, everyone. Thank you for joining me. My name is Grace Jansen. I'm a developer advocate from IBM in the UK. And I sort of specialize primarily on sort of things in the Java and the JVM ecosystem. So reactive, application architecture, cloud native, all of those fun topics. And I'm really excited to be back with the LJC today. This is where I started speaking at the LJC. I joined the speaker clinic. And from there, I've sort of been doing quite a few presentations and meetups and conferences. So it is always fun to be back. So thanks for having me back. So today I'm going to be taking you through we're going to explore sort of the ever increasing demands that are being placed on our applications and what that means in terms of how we can utilize this sort of modern infrastructure that we now have for our applications to meet these increased demands. Then we'll explore some of the key architectural patterns that we can utilize in application development, and that includes sort of reactive application architecture. And then we're going to sort of go into the tools that we can utilize to take advantage of that. And we'll conclude with an interactive lab that you will be able to join in with if you should so wish to. If you don't want to and you're having a relaxing lunch break, totally fine. I'll be showing myself doing the demo as well. So that's sort of the schedule for what we're going to be going through today. So without further ado, we'll get started. So this evolution of modern infrastructure. So we've kind of gone from what we used to have as sort of single core sort of data centers on site to utilizing primarily sort of cloud infrastructure where we can now take advantage of sort of multiple cores, multi-threading. We've got this sort of naturally distributed manner in which our applications are deployed. We've got, we can take advantage and utilize things like virtualization and containerization. And this has all been a fantastic step forward in terms of providing us with a really sort of a really great infrastructure for us to be building modern applications to be able to deal with the increased usage our users in our society now places on our applications. So we can take a look at that in terms of what are those increased expectations and why have they come about? Well, we've had this sort of exponential growth in data over the last decade or so, as you can see here. In fact, in just 8 years, the average person with a connected device will interact nearly 4,800 times a day. So we're creating huge volumes of data from things like IoT devices, from the amount we're spending time on the internet, the number of applications we're using. And our society and people in general nowadays expect this data to be immediately available whenever and wherever they are. And they expect applications to run seamlessly all the time, regardless of the day of the week, regardless of the time, regardless of what sort of increased loads or fluctuations are happening within that application. So that leads me on to fluctuating loads. So, some applications have fluctuating loads depending on, say, the day within the week or, say, the time within the year. And our applications have to be able to deal with these huge spikes, both up and down in terms of fluctuating load on our applications. And not only this, but users have this increased expectation of having the best service quality possible at all times, regardless of what's happening underneath. So we've got increased data, like fluctuating loads and increased expectations, all of which our applications are having to now deal with. And we evolved our application architecture over the past decade or so to sort of reflect this change in expectations and the evolution of the modern infrastructure we're running our applications on. We went from sort of this monolithic on-prem style application towards a more distributed manner or style of application. And that might be macroservices, it might be microservices, you might have even gone to the stage of functions, but sort of where can we take our application architecture in terms of utilizing tools to be able to take full advantage of this infrastructure? So not just to sort of run on the cloud, but to thrive in that environment. So how do we evolve our applications to take advantage of this? Well, there are lots of tools that are available to help us with this, and that includes sort of starting at the very basics in terms of utilizing containers and containerization, utilizing tools and products like Kubernetes or Docker, which you've probably already heard a lot about, and many of you are probably already using. But there are also other tools that we can take advantage of. For example, open source web application servers. IBM's open source application server is actually Open Liberty. And utilizing tools like this, there are alternatives, for example, like Quarkus, which Steve probably knows a lot about. But with this, the benefits of utilizing tools like this is that it enables developers to focus on the code itself, on making fast and iterative changes, being able to easily write tests, and sort of focusing more on the actual logic within your application rather than how you're going to be deploying that and integrating it with other products. So these tools can really help with that. And the fact that they're open source just means that you can help to contribute to them and that they're sort of being developed within communities and in the open. There are also other tools like MicroProfile. So if you're a Java developer and you're interested in Java EE, for example, or perhaps Jakarta EE, you might have come across this before. MicroProfile is a really great community-driven specification where it offers sort of additional APIs and specifications on top of the standard Java or Jakarta EE specification. And you can see here, these are the APIs that they offer. The bottom triangle here at the bottom is APIs that come as standard as part of the MicroProfile stack. So the latest one out at the moment is MicroProfile 3.3. There is 4.0 at the moment, but it is still in beta. It's not been GA'd yet. The ones that are in the top right-hand corner here are actually standalone projects. So these standalone projects aren't yet part of the main stack, but they do hope that they will be later on in development. But we'll talk about some of those standalone stacks later on in this presentation. But MicroProfile can be really helpful in adding sort of APIs or specifications that can be useful when making applications that are designed for distributed environments. So for example, with things like health checks or with config, so externalizing your configuration outside of the application logic so that you can deploy the application in any environment, really useful in a distributed manner. And things like health checks, things like metrics, many of these APIs can be really useful when designing applications designed to be used in the cloud. So utilizing that underlying modern infrastructure. We can also utilize platforms like OpenShift, for example. So sort of taking Kubernetes and maybe taking it that one step further. So these types of platforms can enable developers to sort of run their containerized applications and workloads, and they're powered by Kubernetes under the covers. They can run on any public or private resources, and they help basically make working with Kubernetes a lot easier and a lot more manageable. So platforms like this can be really useful when trying to make full advantage of that underlying infrastructure. It's not just about development though, as every good developer knows, it's also about testing. So to be able to utilize the underlying infrastructure to make better tests, for example. And one such tool that you can utilize to do that is something called test containers. Test containers is actually a Java library that supports JUnit tests. So it sort of provides these sort of lightweight throwaway instances of things like common databases, web browsers, or basically anything else that you need to run that your application relies on within a Docker container. So it really helps to enable you to have this dev prod parity as described in the 12-factor application manifesto. So essentially, you're trying to make your testing environment as close to your production as possible so that you limit sort of the changes that are happening across them and so that you can get as accurate a testing as possible and you're not surprised by any bugs when it actually goes into production. So this utilizes Docker containers, sort of part of that underlying infrastructure within our tests. And as a result, we can basically write self-contained integration tests that can rely on these external resources that our application in production would too. And actually, Microshed Testing sort of takes that one step further. So Microshed Testing is an open source tool that you can also utilize, and it works with any Java EE, Jakarta EE, or MicroProfile runtime. So essentially, in this scenario, Test Containers API that controls the Docker network, and it basically does a simple orchestration of the containers within it. So it essentially doesn't need any extra config files. You just have to add dependencies into the POM and Java code for your testing. And then the Microshed Testing essentially generates a REST proxy for classes. So it's a fairly easy procedure to go through, and it's a great way of enabling sort of accurate testing for your application to make sure everything's fine and dandy in that cloud environment, utilizing that underlying infrastructure. So we've looked at sort of development in terms of utilizing tools. We've looked at platforms. We've looked at sort of testing as well, because that's obviously an important part of our development process, but it's also about how we design the applications themselves. And this is sort of where reactive architecture comes into the picture. So when I talk about reactive architecture here, reactive can mean many different things. And when I talk about reactive architecture, I'm including things like reactive programming, reactive streams, reactive libraries, reactive architecture in terms of the architecture of the actual application. So it's sort of all encompassing, this term, and I'm talking about many different aspects of it. I know you had a presentation a couple of weeks ago focusing on things like reactive programming, Spring Web Flux, Project Reactor, and things like that. So hopefully some of you will already be familiar with this sort of context, but I'll just give you a quick rundown of what I mean by these terms, just for those who weren't able to attend the previous session. So in terms of reactive sort of originally came from this sort of Reactive Manifesto. And this Reactive Manifesto was designed back in 2013 by a group of engineers who were trying to think, okay, what behaviors or what characteristics do applications need to be exhibiting to be sort of classed as reactive and responsive? And it was essentially defining 4 key characteristics that all link together and enable the other characteristics and behaviors. So the bottom is message driven. So having this really asynchronous, non-blocking form of communication within an application through non-blocking messages. And this asynchronous form of communication enables 2 other behaviors, elasticity and resiliency. Elasticity is all about being able to scale both up but also down within our applications, depending on that fluctuating load that I was describing at the beginning. So when you have a high throughput, for example, or a high load on your system, you might want to increase the number of microservices you have or the number of instances you have running. But if you've got, say, a slow day, perhaps it's not the time in which many people are trying to use your application and your load decreases, then you also want to be able to shrink back so that you can be as cost effective as possible. So this elasticity is really important. And by decoupling the microservices through that asynchronous communication, you can individually scale up or down separate resources within your application. Resiliency is another important characteristic and behavior that we want to enable within our applications. And that's because if we don't enable resiliency, our application could fail and completely sort of break down, essentially, if it comes across any type of failure. We do testing and we do our best to try and make sure that failures don't happen within our application, but sometimes it's things that we can't help. It might be an external service we rely on, it might be another application we have to sort of encompass. So failures do happen and we need to build in inbuilt resiliency so that our applications don't completely collapse and fail in the face of these potential failures. And to do that, we can introduce sort of aspects of things like reactive programming, asynchronicity, and reactive architecture. And that leads on to the last behavior or the last characteristic, to be responsive. So to be as responsive as possible to events within the system, to state changes essentially. And by encompassing all of these characteristics and behaviors, we can achieve a really reactive application as our users expect in this modern era. So how do we actually go about building this? We've got a basic application here to sort of show the various levels and layers we need to be thinking about when it comes to integrating these important characteristics into our application so that we can really be reactive, responsive, and provide the best quality of service we can when utilizing this underlying cloud native infrastructure. So the first of those is sort of looking within the microservices. Our applications nowadays are usually made up of, say, microservices or macroservices, and in order to be reactive, we need to ensure that the logic within those different services are asynchronous, non-blocking, and reactive. And to do that, we can introduce the concepts of reactive programming. So what is reactive programming? So I've got a brief definition here just to sort of give an overarching summary of what it means. So reactive programming is all about introducing this sort of style of asynchronous programming. And it's a paradigm where the availability of new information is the factor that drives forward the logic within your microservice instead of it just being by a thread of execution. And you can enable this style of asynchronous programming through various different patterns. And that can include things like futures. So if you're a Java programmer, you're probably already familiar with futures, but essentially it's a promise to hold the result of some operation until that operation completes. There's also things like reactive programming libraries. So for example, RxJava, and there's also small I Mutiny. So they're essentially for designing sort of asynchronous and event-based programs, which is exactly what we're trying to achieve. And then we've also got reactive streams. So reactive streams, we'll talk about a bit more in detail later, but it's essentially a programming concept designed to provide a standard for handling asynchronous data streams while providing non-blocking back pressure. So that's sort of within the microservices, but what about between the microservices? What about if we take a step back and look at sort of the architecture as a whole? This is where we can introduce things like reactive architectural patterns. So how our microservices interact with each other, how they interact with third-party or external services, for example, like message brokers. There are various different design patterns you can utilize. I've just got 4 here that are quite commonly used, and they include CQRS. CQRS stands for Command Query Responsibility Segregation. And that's essentially all about separating out the read and the write APIs to enable really high availability of the information within your application so that you can sort of respond to things like queries, commands, responses. Then we've got event sourcing. Event sourcing is sort of, you might have come across this before through tools like Kafka, for example. Event sourcing is all about persisting the state of some kind of business entity, for example. It might be an order or a customer, and it persists the state of that entity as a sequence of state changing events. And whenever that state changes, it adds an event, it sort of appends it to the end of the list. So it's often used with tools like Kafka. Then we have back pressure. So back pressure is really important when we're trying to create reactive, resilient applications. And back pressure is a form of feedback from a downstream component to an upstream component. And it enables that downstream component to sort of communicate back upstream so that it doesn't get overwhelmed. And it can essentially help to rate limit requests or data or messages coming towards it. And that's to make sure that we don't have a point of contention or blocking that could potentially turn into some sort of failure. And then circuit breaking. So circuit breaking is sort of a similar concept of trying to protect over exhausted resources. So it's where an upstream component is able to temporarily put a block on requests going to a downstream component if that component is under stress or load and essentially needs time to get through those processes and recover. So it puts a temporary block on it, and then once that downstream application or downstream service is back up and running, it can reinstantiate that route. So these are some of the commonly used ones, but if you Google reactive architecture design patterns, you'll find many, many more. So we can utilize reactive programming concepts and reactive architectural design when we're building our applications so that we can really build applications that are designed for the cloud and designed for this underlying infrastructure. What about actually utilizing, which tools and frameworks and toolkits can we utilize to be able to create reactive applications? Well, there's the Reactive Stream Specification that I mentioned earlier. So this is an open source initiative that really was designed by the community, and it's to provide a standard for asynchronous stream processing with that important back pressure I mentioned was an important architectural pattern for reactive. It's composed of 4 different interfaces. So you've got subscription, publisher, subscriber, and processor. And actually it's the subscription part of it that enables that back pressure support. Now, reactive streams is actually utilized in many of the toolkits and frameworks I'll discuss later on. And we'll be utilizing some of it through those toolkits and frameworks in the interactive lab. There's also RxJava. So RxJava is essentially a reactive programming library. So it's a Java library that enables functional reactive programming through things like observables. And we'll actually be using something called Flowable, which is in RxJava 2.0 in our lab later on. So RxJava is a fantastic library to utilize within the logic in your microservices when we're trying to make it non-blocking and reactive and asynchronous. Sort of taking a step back and looking at sort of the broader frameworks, toolkits, and libraries that do actually utilize RxJava and the Reactive Stream Specification. There's many you can choose from depending on the style of your architecture and what technologies you're perhaps using already. So I know that previously you've had a presentation that looked at, say, Project Reactor in a bit of detail. There are also others that you can look at. So if you're interested in, say, the actor-based framework, so perhaps instead of using microservices, you're actually using the actor model, then there are frameworks like Akka, Play, and Lagom that you can utilize. So they were primarily made by a company called Lightbend. They've been open sourced, and they sort of fit together to create an end-to-end solution for a reactive application. But they do utilize this actor-based framework, so slightly different underlying framework. Then you've got things like Vertex, which is a fantastic reactive toolkit that you can utilize, and that's based on something called verticals. So it has this inbuilt event bus, which enables a really asynchronous process all the way through. And that's actually a polyglot framework, so you can use it not just with Java, but also with things like JavaScript, Scala, Kotlin, etc. The one we're going to be focusing on today, and the one that we're going to be utilizing in our interactive lab, is actually that microprofile specification I mentioned earlier. So taking a look back at the stack that I showed you before, the actual APIs we're going to be utilizing, or we're going to be utilizing quite a few, but the one we're going to be focusing on is the Reactive Messaging API, or that specification. So the Reactive Messaging specification makes use of and interoperates with two other specifications: the Reactive Streams Operator one, which is another standalone project, and the Reactive Stream specification that I mentioned earlier, which was that community-driven standard for asynchronous streams. So we're going to be taking a look at this. How does it actually work, though? So MicroProfile Reactive Messaging actually basically annotates application beans methods with two different types of annotations. You've got at incoming and at outgoing annotations. And these annotations essentially dictate whether a method is receiving messages or data or requests, or outputting them to a message broker or to another method within the application. The annotated methods are connected by something called channels. Now, channels are essentially just opaque strings, so you can name them whatever you want, really. You can see at the bottom in our diagram here, we've been able to connect method A with method B through that order channel. So you can see we've got at outgoing order on method A and at incoming order on method B. And then there's also something called an external channel. So for example, if I wanted to communicate with an external messaging broker like MQ or Kafka, for example, I could use an external facing channel, which is actually called a connector. So it's a slightly different name. So you can see here we've got the annotations, the channels, and the connectors, and that's what we'll be utilizing in the interactive lab today. So I wanted to do this interactive lab so that you can take a look at just how easy it is to sort of implement this style of sort of reactive architecture and reactive messaging between services and aspects of your application to really make the most of that underlying infrastructure through tools like this. So we're going to be utilizing an online environment today. This is an online environment we've created with my colleagues at IBM. It means that you don't have to have any prerequisites downloaded onto your local machine, which can be really useful because I know a lot of people can be restricted with that. So I'll put the link, let me just type the link in here. Ooh. I'll type it in the chat so that people can access it easier.
So while you're doing that, Grace, because obviously people, if they're interested following along, want to just press the button and get connected. Are there any questions on what Grace has said so far? If you want to put them in the chat, we can try and do them now, or we'll do them at the end of the session.
Yeah, feel free to put any questions you have in the chat. I'd be happy to answer. I'll give people a few minutes just to sort of get onto the link. If you don't fancy doing it yourself, that's absolutely fine. I'll be doing it on the screen, so you can just follow along with me. That's perfectly fine too. Cool. So when you click onto that link, you should appear on a site like this. It will ask you to log in, but it's just a social login. So you can use GitHub, LinkedIn, Twitter, Google, any of those. Let me just end my presentation so I can see my mouse. Here we go. And when you get onto this page, you'll see that there's actually quite a few modules on here. So if you're interested in perhaps some of the other tools I talked about, so for example, you're interested in, let's say, Microshed Testing, we've also got modules on Microshed Testing as well. We've got modules on things like how to utilize Docker, utilizing Kubernetes, utilizing some of the other MicroProfile specifications and APIs like config, fault tolerance, health, metrics, all of the above. So if you're interested, and also, how to deploy onto various different platforms like the OpenShift platform that I mentioned. So if you're interested in any of those, I'd highly recommend taking a look at some of these other interactive labs in your own free time. They are available all the time, so not just during this presentation. So feel free to check those out. The one we'll be doing is module 11. So if you want to click on module 11, creating reactive microservices using MicroProfile Reactive Messaging, that's the module we'll be doing. When you open it up, this is probably the stage at which it'll ask you to log in, so that might take a little bit of time. But when you open up this sort of module, it will take you to our online environment. Now, this online environment is where we have essentially instructions and our IDE. To open up the terminal, you'll need to go to Terminal, New Terminal, and then it should open it up for you. So essentially, the application we're using here is actually the same application you'll use if you do any of the other modules, which hopefully will make it a bit easier to go between them. But these interactive labs are all based on the same application. So it's essentially got two microservices. You've got the system and the inventory. So essentially what happens is with the system microservice, it essentially takes a screenshot of your computer's like usage, and then it gets sent to Kafka. So we're connecting to Kafka here, and then essentially the inventory microservice consumes from Kafka and updates that every, I think it's 15 seconds. So if here it is. Oh, it's every 15 seconds. Here it is. I'm just going to move my laptop so I can see my screen properly. Hopefully you guys can still see me clearly.
So Grace, just before you get started,
yep.
There are two questions on the chat.
Mm-hmm.
The first one is reactive concept useful for pure native apps? So if you were going to build a native application, is reactive relevant?
I would say there are still aspects of reactive that can be useful. So the manifesto, if you take the manifesto in itself, it's just a description of characteristics, right? And those characteristics can be applicable to pretty much every application. It's about being asynchronous. It's about being responsive. It's about being resilient. And I think any aspect of that you could take and utilize in every application, regardless of sort of what type of application it is, where you're deploying it, etc. So yeah, I think there is aspects of reactive that are helpful to sort of everyone that they could take away and utilize. Okay,
thank you. I have two more. The next one is, can you please talk about the MicroProfile implementations? Can you just list out, because there's some confusion between the MicroProfile as a standard and who are the implementers?
So there's several different implementers. People like OpenLiberty, for example, is an implementer. So IBM implements MicroProfile through OpenLiberty. And then there's also platforms like, I know Quarkus is an implementation of MicroProfile. There's also several others like Pivotal does one, I believe. So MicroProfile itself is just a specification. So if you wanted to use it, you'd have to use an implementation, and those implementations vary in terms of what they offer. So for example, in this interactive lab that we'll be doing, I'm going to be using the OpenLiberty implementation. And as part of that, I'll be using the OpenLiberty's implementation of MicroProfile Reactive Messaging. Now, what that means is that I have, for example, I'm going to be utilizing the OpenLiberty connector to Kafka. Now that's a different implementation to, for example, Quarkus is connected to Kafka, and Quarkus has other connectors to perhaps other external messaging brokers that OpenLiberty, that differs to OpenLiberty's, as one example. So MicroProfile is just a specification. You need to look at the specific implementations to know sort of which one you want to use and what they offer specifically.
Okay, and how would somebody find that list?
So if you go onto the MicroProfile website, it shows you the different implementations.
Okay, cool.
So in fact, I can probably get it up.
But I think that's fine. So I have two more questions for you.
Yep.
The first one is there any relationship between Spring ecosystem and MicroProfile?
I'm not familiar with the Spring ecosystem. So if they can send me a link to that, I can take a look and maybe get back to them.
Okay.
But I'm not sure, sorry.
Okay, and the next one, which I think is an interesting one, point out. So debugging or tracing reactive programs are quite challenging. Any idea on how to address the challenge?
That's an interesting question. I've had that before actually, and I guess to me, it's not about it being reactive. To me, it's the same problem you have when you introduce asynchronicity and a distributed way of deploying your application. Because as if an application didn't necessarily count itself as reactive, or perhaps didn't use some of the reactive frameworks or toolkits, but was using a microservices distributed infrastructure and had, say, Kafka under the covers, it was very asynchronous, you'd still have the same debugging or tracing problems. So I'd say that in terms of addressing the challenges, it's about making sure that your APIs between your microservices are really clear, enabling things like there's a MicroProfile API that you might be interested in, which is basically tracing essentially the debugging process. So it's called open tracing. So that might be one that you might be interested in. But I'd say I don't find it specific to reactive programs, but instead just to distributed applications that have a form of asynchronicity within it. And it is a challenge for sure. And it's something that I think the industry is trying to tackle more. Experience with Vertex. Oh, interesting. Okay. I guess personally, I didn't necessarily. So I built a small Vertex application with a colleague of mine called Kate. And I didn't necessarily struggle with debugging, but we didn't have that complicated an application. So yeah, I'd say you'd have to take a look at the Vertex website for that. Or perhaps Steve, perhaps you know someone that could get in contact for that.
I don't know. It depends on what the problem is.
Yeah.
Okay. So look, we have one more, and then I think we should get on to your interactive thing and then do the rest at the end. So it says, are MicroProfile specs Graal VM ready, or is it totally up to implementer? Well, the answer is it's totally up to the implementer. Yes.
Yeah.
Okay. So if you want to get back, and then we'll do the Q&A, and yeah, so we can open up to people chatting and asking great questions at the end, if we can fit it all in. So Grace, if you want to get on and do your piece.
Absolutely. Thanks, Steve. So we'll just continue because this first page is just introductory stuff. So with this this sort of online environment, we've done it in a way so that you can just click this button in the corner here to copy any of the sort of commands that you need for the terminal. So if you just copy those commands, and then you can paste into the terminal on the right-hand side. So we're essentially just git cloning our guide MicroProfile Reactive Messaging repo, and then CD into our sort of folder guide MicroProfile Reactive Messaging. So we're going to CD into a start. So if I do an ls, you should be able to see we've got things like start and finish. Now with all of these guides or all of these interactive labs, we have a start and a finish repository or directory within it. And essentially the finish directory is where you'll find the finished application that you should be building at the end of this lab. So if you'd like, at the beginning of every lab, you can go into the finish one and see how it should work, if that's helpful to you. It can also be helpful if anything goes wrong partway through and you want to check whether it's something you perhaps done wrong, you can compare them. But in this case, we're just going to go straight into start because we want to go all the way through the instructions and create this and sort of follow this lab. So the first thing we're going to do is we're going to create the system service class. So we've just created a touch command to make this a bit easier. So that should create it for you, and then you'll just need to open it up. Two different ways to open it up in this environment. Either open up the file system here, or you can go to File, Open, completely your choice. So in this case, the instructions tell you where to go in these little helpful hints here. So we're going to go to Guide MicroProfile Reactive Messaging, into Start, like I said, and then we're going to go into System, SRC, Main, Java, IO, OpenLiberty, Guides, System, and there's our system service.java class that we just created. So if you want to go ahead and open that up, it should be empty because we've just created it, but we've got all the code you need to copy and paste in here. So because this is our system service, which is the one that's going to be publishing our data to Kafka, we're going to actually be using the outgoing annotation. So that's the MicroProfile specification, or the MicroProfile annotation I mentioned as part of the MicroProfile Reactive Messaging specification. So we're going outgoing to a topic called system load in Kafka. I mentioned earlier that we're actually utilizing RxJava as part of this as well. and we're actually utilizing the flowable function here. So this flowable method is essentially used to set the frequency of how often our system service is publishing the calculation to the event stream. So in this case, we've chosen 15, I think it's 15 milliseconds or 15 seconds. Oh, there we go, seconds. And you can see that we just imported these at the top here. So we've got the RxJava flowable, and we've got MicroProfile Reactive Messaging outgoing as 2 imports that we're utilizing. And as I said, we're also utilizing the reactive stream specification through the MicroProfile and OpenLiberty implementation. So now that we made system service, we're going to continue on. And next, we're going to make the inventory resource class. Just close these. So again, just copy and paste that command in and hit enter. Please remember when you're making these classes, please remember to save. You can save with Command S or Control S, depending on the device you're using. So now that we've made our inventory resource class, we need to go ahead and open that up. So we're going to open guide microprofile. Again, we're going to start because that's where we are at the moment. This time we're going to go to the inventory folder. And again, to SRC, main, Java, IO, OpenLiberty, guides, inventory, and there's our inventory resource.java class. So again, open that up. It should be empty because you just made it, and copy and paste this text in. So this time, because it's the inventory resource class that we've just made, it's actually the one that's going to be pulling from Kafka. So in this case, we're using the incoming annotation, again, to the same topic in Kafka called system load. So this time we're actually taking the information in instead of publishing it. So we're using the @incoming. And you can see that change at the top here with the @incoming import. So if we continue on. So the next thing we need to do is create the config properties file. So as well as utilizing the MicroProfile reactive messaging specification, we're also utilizing the MicroProfile configuration specification or API. And what that allows us to do is essentially externalize our configuration, which is really important when we're deploying to cloud infrastructure so that we can essentially deploy it on any environment without having to change the application logic itself. So now that we've created that, we're going to go ahead and open it up so that we can edit it. So if we head to guide MicroProfile Reactive Messaging, this time we're going to head to, again, start, system, SRC, main, but this time we're going to head to resources. So resources, meta-inf, and there's our MicroProfile config.properties file. So we're going to open that up and then copy and paste what we've got here for you in. So here you can see that we're actually essentially utilizing the MicroProfile messaging outgoing annotation, like we said, because this is the system microservice, and we're utilizing a connector. Now in my presentation, I explained that a connector is just an external form of a channel. So we're utilizing the OpenLiberty connector to Kafka. That's why it's called Liberty Kafka, and this is where different implementations will differ. So if perhaps if you're using something like Quarkus, it will be a different name. But we're utilizing the OpenLiberty connector here. We've set the topic that it's going to be going to system load topic. And we've got a serializer here. Now the serializer essentially enables us to basically turn an object into a JSON so that it can be configured correctly for Kafka. So now that we've created the system MicroProfile config properties file, we need to create the inventory one too. So if we do that command, again, just click enter and find it in your file system. So guide MicroProfile, start, inventory, SRC, main. Again, this time we're going to resources, meta-inf, and then MicroProfile config.properties. Again, should be empty, but if we copy this in and save. So again, we're utilizing that same connector, but this time we're utilizing it for the incoming connection through that incoming annotation. We're still utilizing the same topic, but the great thing about having this sort of configuration is that if, for example, 2 different teams were making the 2 different microservices in this application, you wouldn't necessarily have to name it the same thing. So you could have a different name for it within the microservice, but still referring to the same topic on Kafka, which is obviously great. So you don't have to sort of make sure all your configuration lines up across microservices, which can be tricky when you're working with remote teams, for example. In this case, we've got a deserializer because we're actually taking it from Kafka. So we're trying to turn it back into JSON this time. And the interesting part that we have extra in this one that we didn't have in the last sort of config properties file is this group ID. And that's because it's a consumer from Kafka. And sort of consumer groups is a concept within Kafka that enables you to have multiple consumers consuming from the same topic without having clashes in terms of reading the same record, for example. So having this group ID allows us to form a group, form a consumer group when we're consuming from Kafka. In this case, we're only running one instance of the inventory microservice, so there's no one else in our group. But if we wanted to run multiple instances of it, then they'd all become part of that consumer group, so they wouldn't interrupt each other reading or duplicate the same record when reading from Kafka, which is really helpful. So if we continue on, this time we're going to create the server.xml configuration file. So again, copy and paste that command in, and then if we open it up, guide MicroProfile, and then go to start, and then down to system, SRC, main, this time Liberty, config, and then server.xml. So if we go into this and then copy, and again, remember to save, because otherwise there will be issues when we're trying to deploy this later. So now you can see that we're actually importing this feature here, the MicroProfile Reactive Messaging one. You can see some of the other MicroProfile features that we're making use of, like MicroProfile config that I mentioned to externalize that configuration. We're also making use of things like MicroProfile health to check the health of our microservices and that they're ready to be deployed. So this is really important for us to consider. Fantastic. So now we're going to create the pom.xml file. The reason you don't have to make the server.xml file for the inventory system or service is because we've already done it for you, because it's exactly the same. So you can take a look at it if you'd like to, but they literally match word for word. So we just wanted to show you one. So we'll go ahead and make that pom.xml file. So if we go to File, Open, and then go to Guide MicroProfile, Start, and then to System, make sure you're selecting the right POM. They are awkwardly next to each other. But make sure it's the top one. Should be blank when you open it. If it's not, you've opened the wrong one. So then we can copy all of this. It's a bit long. And make sure you save again. So in this, we can actually see the different plugins that we're in, the different dependencies essentially we're utilizing. So you can see here, we're actually utilizing some of the Microshed and test container things I was mentioning about sort of testing in as close to production as possible. We're also utilizing that RxJava tool that I mentioned, that reactive programming library. We're utilizing Apache Kafka, obviously. And here's that MicroProfile reactive messaging dependency we need for all of the annotations we're utilizing. But we're also utilizing the more generic MicroProfile specifications that come as standard as part of the normal stack. So you can see here all the dependencies we're utilizing. Okay, so we're going to go ahead and essentially run the Maven install and package goals. So again, just copy and paste, should be fairly easy. Do let me know if anyone is coming across problems or struggling with any of this, or if I'm going too fast. There we go, so let's do an MVM package. The next Docker pulls are just to make sure we've got the right version of the different sort of images, Docker images that we need to utilize for this. And that's because we're sharing this environment with other people, so they might have accidentally pulled different versions that aren't necessarily going to work with this application. So we can do those Docker pulls now. Again, you should be seeing lots of green completes, hopefully when you're running these. If not, please do let me know via the chat. So with this, because we're utilizing Kafka, at the moment, Kafka still needs Zookeeper to run in order to store the metadata that it needs. In future, they're hoping to essentially create a topic within Kafka to hold that metadata. But right now, it does mean that you do still need to run Zookeeper to be able to run Kafka. So that's why we've got the Zookeeper sort of dependency as well as Kafka for this particular application. Once those Docker pulls have completed, though, we can then start the Docker builds for our 2 microservices. As I said, we're only running one instance of each. So it literally is just one microservice for system and one microservice for inventory. If you want to run more than one, that's totally fine. You can do that as well. There we are. So now that those are run, we can essentially run a script that we created to start our containers. It will take a little bit for our containers to get up and running. Once they do get up and running, what we're going to be doing is essentially trying to hit the, or send a request essentially to the /systems endpoint of the inventory service. So what we're doing is our system microservice will be, every 15 seconds, we'll be taking calculations of our machine load and sending that to Kafka. And hopefully, if our application is up and running correctly and we've done all our annotations correctly, what should be happening is our inventory service should be pulling that data from Kafka and displaying it for us via this systems endpoint. So that's essentially what we're going to be testing with this curl command. We're testing that we can get that information from the inventory microservice through Kafka originally from the systems microservice. So as I said, it might take a little bit of time. Huzzah, cool, I've left it enough time. So you can see here, we've got my host name and my system load. And this system load is the part that should hopefully change. Yep, you can see it's changing because it is updated every 15 seconds. So every 15 seconds, you should be able to see some sort of change within that system load number, which shows that our application is working correctly, which is exactly what we want to see. So we are successfully sending through MicroProfile Reactive Messaging messages from one microservice to Kafka and then consuming from Kafka and being able to show that through an endpoint in our second microservice. Now that we've completed all of that, we'll just need to clean up our environment. So we need to do a stop containers. And this is important because this environment essentially saves your progress. So if, for example, you were going to move on to a different lab after this, you would definitely need to have sort of teared down your environment and cleaned up your environment, because otherwise you won't be able to run the following labs because it will already assume there's containers running and you'll have a really messy file system going on. So I would definitely recommend cleaning up after you complete each of these labs, just so you don't get any confusion or errors because of it. And it's as easy as that. So we are complete with the interactive lab. As I said, there are lots on our environment. So if you fancy having a go at learning how to deploy to some of the other tools that I mentioned in this presentation that are also really helpful in sort of enabling your application to take full advantage of that underlying modern infrastructure, then definitely check out more of these labs here, including ones on OpenShift, different microprofile specifications, Kubernetes, Docker, Microshed Testing, and many, many more. So feel free to do this in your own time. But for just now, I think we'll take any questions that you guys have.
Wow, thanks, Grace. That was a whirlwind.
Yeah, sorry.
It's all right. Okay. So Suvik, you left the last question about you want to talk about your experiences. Is there anybody else who wants to have a conversation with Grace? About something technical, of course. Okay. Well, look, okay, so if I'm going to try and do this, so Suvik, I'm going to try to get you to, I'm going to press this button that says unmute. Okay.
Hello, hi, good afternoon rather. So it's, yeah, okay. The reason I asked that question was that when we talk about, I just spoke about the concept of verticals and vertex, what usually happens is that when the communication goes across verticals, when you're passing data across verticals, it becomes a real challenge to trace it. And that is why the experience of, how do I trace information? Now, this is a question which has been discussed in other forums as well. A shameless plug that I'm also one of the coordinators of the Bangalore Java user group. So that's the reason we also discuss these questions within our community. So and also, there was if you follow Java, there's an interesting project coming up, which is the project Loom, which kind of is a competitor to the whole reactive programming paradigm. So it's like a 15-year-old Java program can now work as well as a reactive program written today. Anyways, that's a conversation another day. So the viewpoint which we got from the community was that instead of trying to debug or trying to debug the information being passed across verticals, let's try and do the information or the business logic which you're writing in the vertical to be as robust, similar to what you said, that your APIs are clear, they know the purpose they are solving. So that's one approach, but it's still, it's more of a framework level challenge rather than of a reactive programming challenge. So if anyone has in the audience or among the speakers have any background on, for example, they've used another framework like say Akka-based frameworks, where they find actor-based frameworks like Akka, where it is much easier to figure out what information will pass from one component to another. So that's the reason I thought I brought up the question.
Okay.
Thanks for bringing it up.
Yeah,
I'll try and investigate it and see what I can find out for you. And if I find anything, I'll I'll try and reach out.
You can come back, Jake, Grace, and do a whole how
Thank
to
you. Thanks.
how to debug Vortex. Yeah, I think the biggest problem that everybody is faced with when we were doing standard design architectures, it was reasonably straightforward to debug, but still not super easy. And then of course we go to distributed, as you said, and it gets more complicated. And now we're asking people to take that asynchronicity and apply it and actually write code directly like that. And I know just how hard it can be to do those sorts of things. So I'm not sure there's an easy answer. And I suspect that we're still catching up in the frameworks to make it easier to do this stuff. But it's sort of what it is at the moment. Yeah. Okay, we have 10 minutes left. If you've got anything else you'd like to bring up, Grace, are you okay? Done?
I don't think so. I think, yeah, I feel like I've bombarded everyone with all that information. I apologize if I went quickly.
Okay, and so the
but you can reach me on Twitter or on the LJC Slack channel.
Okay, and Suvik says he has one more question.
Yeah, so sorry to hog the limelight. Apologies for that. Grace created an excellent example, that test containers are kind of how you implement one of the 12 factors, which was dev prod parity. So has anyone come across an article which talks about how you do all the 12 factors? Because I can understand how you do dev prod parity with test containers, but there are other factors as well. So I find this to be a really interesting topic to understand about, because it's very easy to read the 12 factors, but how do you do it? Because it's the what it is and why it is makes sense, but the how is the unanswered part here.
Yeah, I mean, I have an article on Open Liberty website that I can forward to you, written by Emily Zhang, if you're familiar with her. She I think spoken in the LJAG a couple of times and is quite prolific in the MicroProfile community. She's done a 12-factor app presentation that's available in a recording through that blog that I can send to you, if that would be helpful.
That would be excellent. Thank you very much. Because I was, I've been trying to talk to within my organization about why we should dual factor. And the most common question which people ask, okay, you've told us what to do, why you should do it, but please tell us how to do it as well.
Mm-hmm.
So I think that would be really helpful, Grace.
Yeah.
Thank you.
I think you are not alone in that the very, very, very many Java developers are in the same situation where they understand. We all understand that we have to change how we do things because of these new demands and new architectures. But that step of what's the next thing to do and how to do it and how to debug it and consequences on build and all sorts of stuff is exercising everybody's brain. So don't feel it's just you. It's sort of the whole world. Yeah. Okay. So
no, the point is that if at least, okay, sorry for that.
No, carry on.
No, the point is that if you ask the questions, somebody might take up the effort, as at least Grace is like helping me answer it. So at least I'm coming back with something.
Yeah. No.
I'm thankful for that.
Yeah, I don't mean to imply that people aren't trying to do that for you, but I'm just saying you are asking the same questions as everybody else, and we are trying to figure out. I think a lot of people are trying to figure out how to get that information so that you can see how things are done, because it's a common thing. Yeah. So look,
I mean, I'm currently writing one that takes it a step further, that goes to the 15-factor app. So I'm writing the article at the moment. So when it goes live, I'll put it on my Twitter and you can take a look.
Oh, that's great. That's good. I've read the 15 factor. I think it was probably a VMware blog which talks about this one. So I'll not interrupt anymore. Sorry for that.
Yeah. So look, we have there's a couple more questions on the chat. Jamie wants to know, is Open Liberty planning to get the same performance as Quarkus? I hope not.
The same what, sorry? Performance.
Okay,
so there's a really interesting article that you can read on this, where we show you all of our performance stats. So if you head to the IBM developer website, in fact, I think I had it in my maybe I didn't have it in my presentation. I'll put it up as a link after, but there's a blog written all about Open Liberty's performance and sort of comparative stuff. So you can take a look at that if you'd like to.
Okay, and we have one last question, because then I'm going to stop. And the question is MicroProfile and Jakarta EE, are they two separate things, or is one an extension of the other?
They are two separate things, absolutely. So Jakarta EE is an open source, essentially, version of Java EE. And so it's essentially the language. MicroProfile is a specification that can be sort of built on top of that. So built on top of either Java EE or Jakarta EE, which adds additional APIs and specifications that enable sort of the qualities and behaviors we want from distributed applications. Hopefully that's a condensed answer for you.
Okay, right. Well, thank you, Grace, so much for coming along and talking. Yes, can you, were you going to share your materials at all?
So I've shared a couple of links in the chat. I've just shared the other one about the IBM developer article.
Okay.
I can send across my presentation if that would be helpful to the LJC.
Yes, if you can
organisers.
send that to Dom, and I'm sure she can put it in the right place. That'd be cool. Okay, right. Well, thank you so much. And I'm going to declare the success, and I'll say thank you very much for coming, and we'll see you all next time.
Thanks all.
Okay, thank you. Bye-bye.